Hi, all. Let's take a look at the short section 5.6 homework assignment on Achieve. The first question here, it's a simple example in which we're given a rate of change and then asked for how much the quantity has changed over an interval. So we know that we're going to integrate that rate of change, which in this case is the change in the amount of water with respect to time, and we're supposed to find out how much the quantity of water in the reservoir has changed after 5 hours. So in my example, it says water flows in an empty reservoir at a rate of 3,000 plus 240 T liters per hour. And then I'm supposed to find what the quantity of water is in the reservoir after 6 hours. So in simplistic cases, we can just say that the amount would equal the rate times the time. But the problem with this one is that the rate is a function in and of itself. So that's why we have to use integration in a problem like this. And we say, well, we're just going to integrate from 0 to 6 of that rate function with respect to time, and we'll get our quantity function, the quantity function being 3,000 T plus 120 T squared. Then we're going to evaluate that from 0 to 6. Of course, the only answer we're going to get is when we evaluate it at 6, because when you plug a 0 into that, you'll get a 0. When I plugged in a 6, I got 18,000 plus 4,320 for a total of 22,320. That should be the amount of liters changed in this problem. We'll go ahead and put that answer in, 22,320, and we'll check that answer, and Achieve likes it. Okay, so now for the next question, it's going to be similar. It says, suppose a survey shows that a mayoral candidate is gaining rates at a rate, or is gaining votes at a rate of 2,300 T plus 1,000 votes per day. Now it says T is the number of days since she announced her candidacy. How many supporters will support the candidate after 65 days, assuming that she had no supporters at day 0? So if that is the rate of how her support is increasing on a daily basis, then we can just say then on 65 days, we'll just integrate from 0 to 65 of that rate with respect to time to get the number of supporters at any specific instance from, in this case, 0 to 65 days. So the integral of that rate function gives me 1,150 T to the second plus 1,000 T. We're evaluating that quantity function from 0 to 65. Yet again, the only answer you're going to get is when you plug in the 65. Of course, the original support was 0. That's why f of 0 is 0 in this case. When I plugged in the 65, I've got 4,923,750. As you see, we plug that in, and Achieve says absolutely. For the next question here, again, it's the same type of concept. This one is getting to where I like the physics application. Find the displacement of a particle moving along a straight line with a velocity of 22 T minus 9 meters per second over the time interval 2 to 7. So since displacement just means we want to find the change of position, not necessarily the total distance traveled, then the displacement or the change of position is simply the integral from 2 to 7 of your velocity function, 22T minus 9. It's going to find the total change of placement between 2 and 7. Of course, when we integrate that, we'll get our 11T squared minus 9T. And then when we evaluate it at 7, that's 11 times 49 minus 81. I got a 476. We always subtract the lower limit of integration. For that, I had 11 times 4, 44 minus 18 to give me a 26. Upper limit minus lower limit gave me a total of the change of placement, or the displacement in this problem, from 2 to 7 seconds. It increased 450 meters in whatever would be considered the positive direction. Now, the next few problems are going into where it's the first one here, and you've seen this in a few of the previous sections, where it's just asking you to expand out a product. Again, I'm not quite sure why they're including that here, other than, like I said, whenever we integrate, anytime you can do algebra, you must do that first before you worry about the integral, since there is no integral product rule. But it's just having you do a distribution of a trinomial times a binomial here. The work I did for that is right here, where I took 4x to the fourth plus 4x squared plus 3 times 8x squared plus 8. You distribute the 4x to the fourth through the second group. You get your 32x to the sixth plus 32x to the fourth. You distribute the 4x squared throughout the second group, and you get 32x to the fourth plus 32x squared. Then finally, you distribute the 3 through the last group, and you'll get 24x squared plus 24. Gathering like terms, I got 3x to the 6th plus 64x to the 4th plus 56x squared plus 24. I match that with their answer, and it's the first one on mine. And I'll say check the answer, and it says yes. We go on to 5. 5 is another one. It's just having you do an algebraic problem. And in fact, you can see I put it at the end of my assignment because I completely overlooked the fact that there was a little bit of work to show on these. So I tried to show my work on number 5 here. It gave you the function p of x, and it asked you to evaluate it at 6. So in this case, we just have 9 times 6 to the fourth minus 8 times 6 squared plus 6. You can get it as I've typed in there, or something I would like you to get used to doing if you're not already accustomed to doing it, is using your calculator to evaluate something like this. The way I would like you to do it on the calculator is to store variables in. I'll say 6 store x. Let's see if I can make that a little clearer. Yeah, a little better. So I'll store 6 in for x, and then colon. You hit alpha decimal for the colon, and then you type in whatever function. In this case, 9x raised to the fourth minus 8x to the second plus 6. Of course, you don't have to do it this way. It's an easy problem no matter how you do it. But this is one quick and easy way, and especially useful if you have multiple variables in your problem that you're trying to evaluate. You just don't want to sit there and plug them in yourself. So I'm getting 11,382 for this one. I'll go ahead and enter that in. Check that answer, and Achieve says absolutely, of course. For the next question here, this is where it will want you to watch their media, in which it's going to explain the displacement over a time interval as just the integral from where the motion begins to where the motion ends. Yet on the other hand, the total distance traveled, you're going to have to take the integral of the absolute value of the velocity function. So it is wise to go ahead and watch that. I'll go ahead and just hit play to get credit for the problem, and hope that you watch it as you work it. Number 7 here. It's giving me a problem in which it applies their earlier algebra, where it's giving me a rate of time, but that rate of time is a product, where in this case, the rate of time is representing the growth rate of a population of rabbits. And I'm supposed to find the net change in the rabbit population over the first 14 days, round to the nearest integer. Well, the net change, that's just going to be the increase or decrease in the number of rabbits. So all I have to do is say, well, it's going to be the integral from where the population began growing to where it ended growing, 0 to 14 days of my population function. Now notice on that population function, I had to have that out as a polynomial. So this original p prime of x, the growth rate of the population of rabbits, I had to say, well, I'm going to multiply the two polynomial portions. It's much easier if you'll just keep the 0.02 out in front. And then that 0.02 can stay out in front of the problem the entire way. And I would liken this to whenever we found the area under a curve using left or right hand rectangles, remember, we didn't say every single one of those bases times the height, bases times the height. We said the summation of the heights all times the common base, delta x, and that delta x was brought out in front. In the same manner, I can just bring this 0.02 out in front of the integral times the summation of the heights inside of that interval. Much easier this way. So now, when you evaluate this function at 14 and then multiply by 0.02, you're going to get the answer of 177.147. The problem said round to the nearest integer, so obviously in my case, that's going to be 177. Now, keep in mind, I didn't even worry about the lower limit because that polynomial evaluated at 0 is going to be 0. Should just get the 177. And it says absolutely for number 8 here. For number 8, it's saying a cat falls from a tree at time 0. How far does the cat fall between 0.2 and 0.7 seconds? And use Galileo's formula, the velocity is equal to negative 9.8 t meters per second. So I can say, well, that's just the velocity due to the force of gravity. So if I'm trying to find the displacement, how far that cat has fallen, then I can just go in there and say it's the integral of your velocity function from 0.2 to 0.7. And then I can say, well, when I integrate that, I'm going to get negative 9.8 t squared over 2, which is negative 4.9 t squared. Now you're going to evaluate that from 0.2 up to 0.7. When I evaluated at 0.7, I got 2.401. Notice I just kept the negative factored out in front. And then I said minus the lower limit, which is 4.9 times 0.2 squared, and I got 0.196. Upper minus lower gave me 2.205. I knew it was going to be negative. Now, I don't want to put the negative in my answer simply because the question asks, how far does the cat fall? So since fall automatically implies the negative, you wouldn't say that the cat fell negative 2.205 feet in this, or sorry, meters in this case. That wouldn't make sense. If you fall a negative, does that mean you're going up? We know the cat's going down. The problem says fall. So I'll say, well, then the cat fell 2.205 meters. And I do not want the negative in that answer. 2.205, boom, yes. Up next, says a particle in a straight line with a given velocity v of t is 40 minus 10t. Find the displacement and the distance traveled over the time interval 0 to 8. Okay, so I like this one because it's asking us for both. Remember, the displacement's always the easy one. It's just the integral from where motion begins to where motion ends of your velocity function. And then in this case, notice the displacement is 0 because if I just integrate from 0 to 8 of my velocity function with respect to time, the integral of that velocity function gives me 40t minus 5t squared. When you evaluate that from 0 to 8, then you can say, well, you plug in the 8, you'll get 40 times 8, which is 320, minus 5 times 64, which is also 320. You'll get 320 minus 320, 0. Your lower limit, also 0, because that polynomial evaluated at 0 is 0. So we just get a displacement of 0. So that's making you think that, well, then the particle didn't even move in that region. And that's not true. It certainly did move, but whatever forward movement it had as much backwards movement, and its ending point was the same as its beginning point, thus its displacement was 0. Now, the total distance traveled, I have to think about every movement as a positive movement. So I can go in and say, well, then I need to think about what the absolute value of 40 minus 10t is. And what I did for that is I just set 40 minus 10t equal to 0 in my head, and I said, well, that's going to equal 0 when t is equal to 4. All right. Well, then for any value that's less than or equal to 4, 40 minus 10t is going to be a positive number. Like if t is equal to 2, then your velocity is going to be 20, positive 20. That absolute value doesn't do anything in that region. So for any value of t between 0 and 4, your function doesn't need the absolute value. However, for values after 4, your velocity would be negative. You'd have 40 minus 10 times a number larger than 4. That's going to give you a negative number. We need that to be a positive number, so the absolute value is going to change the sign of that function for any value of t greater than 4. So then for the total distance traveled, you'll just say, well, between 0 and 4, you just integrate your function with respect to time. But then between 4 and 8, we know that we need to subtract or change the sign of my velocity function in that region. And so I say minus the integral from 4 to 8 of 40 minus 10t with respect to t. And now I can go in and say, well, all right, just as above, the integral is just 40t minus 5t squared. We're evaluating that between 0 and 4. That's going to give you 40 times 4 is 160. Minus 5 times 16 is 80. 160 minus 80 is 80. Notice, you don't worry about the lower limit. We already knew that was 0. So you get 80 minus 0 is 80. Now it's 80 minus whatever this second group evaluates to. Just as above, we already know that this group evaluates to 0 when we plug in an 8. You'll get 320 minus 320. So you say, well, the upper limit for that second group is 0 minus the lower limit, excuse me, the lower limit here, when you plug in a 4, just like before, we'll have 160 minus 80 for an 80, but it's upper minus lower. I could see a lot of people making a silly mistake and getting an answer of 0 here. It's 80 minus a negative 80. Those combine and tell you that your total distance traveled is 160 units. So all this is saying is that in the first 4 seconds, it moved 80 meters in a direction that would be considered positive. In the last 4 seconds, it moved in a direction that would be considered negative. Thus, the overall displacement was 0. But we have to understand that the total distance traveled was 160 meters. We put that in for the second portion here, and it likes it. For the next one here, number 10. We have our velocity function here given, 4t to the negative 2 power minus 1. And yet again, just like the last problem, it's wanting us to find the displacement of a particle, this time on the interval from 1/2 second to 5 seconds, from 1/2 to 5. So the displacement, again, just like last time, super easy. It's always the integral from where the motion begins to where the motion ends of your velocity function integrated with respect to time. So power rule says 4t to the negative 2 becomes 4t to the negative 1 over negative 1. Minus 1 becomes minus t. Evaluating that between 1/2 and 5. Before I evaluated, I wanted to simplify that function to make it look better. This is the same thing as negative 4 over t minus t. Now, when I plug a 5 into that, I get negative 4/5 minus 5, which gave me negative 29 over 5. You always subtract the lower limit. The lower limit here would be negative 4 over 1/2, which is going to be negative 8. And then minus 1/2, that ended up giving me a negative 17 over 2. But we know minus a negative is plus a positive. 17 over 2 minus 29 over 5 ended up giving me 27 over 10 for the displacement. Now, the reason I left that as a fraction as opposed to a decimal is the instructions on the page said use fractions when needed. So I left it as a fraction. That implies to me that they don't want the answer of 2.7 meters in this case. Anytime they want a decimal answer, they'll say round to so many decimal places. So I'm assuming they want the fractional answer here. Similarly, now I found the total distance traveled. Before I could do that, I had to think about when the absolute value is going to change the sign. So what I did is I set my original velocity function equal to 0. And I said, well, if the velocity function equals 0, then 4 over t squared is equal to 1. Now, if you multiply by t squared on both sides, that's going to give you t squared is equal to 4. Square root t equals 2. We know that we can't have negative times, so you don't have to worry about the positive and negative root. So the only value of time in which this velocity function is going to equal 0 is at 2. So now I'm thinking about it and I can say, well, all right, for any value before 2, the absolute value, it's not going to do anything. Because think about that. What if t is 1, for example? You would have 4 over 1 squared minus 1. You have a positive velocity of 3. You don't need the absolute value in that region. However, for a value of t after 2, like when t is 3, you're going to have 4 over 3 squared. That's 4/9 minus 1. That's a negative velocity. So the absolute value is going to have to change the sign in order to make that velocity positive in that region. So we have our piecewise function equal to the absolute value. So now for my distance formula, the motion began at 1/2. From 1/2 all the way up until 2, I can leave the function alone inside of that integral and integrate it with respect to time. However, for values after 2, until the motion ended at 5, I have to change the sign of the function. So you'll notice that's just why I subtracted this second integral. That's probably the easiest way to do it. Then I can say, okay, then I'll integrate this function from 1/2 to 2, subtract the integral of that same function from 2 to 5, which I know this is going to give me a negative value. I'll subtract it to make it positive. So when I plugged a 2 into the first function, I got a -4. When I plugged a 1/2 into the first function, I got the negative 17 over 2, but you're subtracting the lower limit, makes it plus 17 over 2. So I'll save you from having to watch me enter that into the calculator, but these were just calculator steps, entering the 2 into it, and then entering the 1/2 into it to get minus 17 over 2, but you subtract the lower limit that makes it plus. Now we subtract the answer we get for the second group, which is the upper limit, -4/5 minus 5 for -29 over 5. And then evaluating at 2, again, that'd be -4 over 2 minus 2. That's going to give us a -4, but you're subtracting a -4, which makes it +4 there. So now I have the answer for my first group, and I know the answer for my second group is going to be negative. That's why we're subtracting it, because of all of this. And whenever we do, the answer for the first group I got was 4.5. The second group would have been a -1.8, but we're subtracting, it makes it plus 1.8. I got a 6.3. Again, I don't think it wants a decimal answer for this problem because it said fractions are needed. So I'll put my answers as for the displacement, 27 over 10. So 2.7 units. And of course, the total distance traveled is always greater than or equal to the displacement. In this case, it's greater than. I don't want the decimal. I want the 63 over 10 to represent that. And I believe these answers will make a chief happy. And they do. For number 11, it's a very quick one. It's just asking for the net change between 4 and 5 with the acceleration function 16t minus 4t squared. If I want the net change in velocity with this acceleration, well, then the net change in velocity is just the integral from where the acceleration begins to where it ends, 4 to 5, of your acceleration function. We integrate that to get, and it's just using the power rule, 8t squared minus 4/3 t cubed. If you evaluate that group at 5, you'll get 100 over 3. If you evaluate that group at 4, you'll get 128 over 3. Now it's upper limit minus lower limit. So in this case, I'm getting -28 over 3. And unlike the last problem, it says give your answer to 2 decimal places. So instead of leaving it as -28 over 3, I have to put -9.33 meters per second to fit what they want for their answer. We put that in and no problem. Now, for the last one here, it says that traffic flow rate past a certain point on a highway is Q of t is 1100 plus 2500 t minus 390 t squared, where t is in hours and t equals 0 corresponds to 8 a.m. How many cars pass by during the time interval from 8 to 9 a.m.? So what I have to do is think about this here and say, well, if t is equal to 0 is going to correspond to 8 a.m., then the number of cars that pass by is going to be the integral from 8 a.m. to 9 a.m. You have to assume that if 0 is representing 8 a.m., then 1 hour later, 9 a.m. is going to be represented by 1, and you put your quantity function in there with respect to time. You integrate that to get to 1100t plus 1250t squared, plus it'd be 390 over 3, which gives me minus 130t cubed, evaluated from 0 to 1. Well, clearly when you plug a 0 into this, you get a 0. So your answer is just when you plug in the 1. When you plug in the 1, you're just going to get 1100 plus 1,250, which will give you 1,360 minus 130, which is going to give you your 2,220. Now, when I try that, 2,220. So that's the number of cars that pass by in that hour, according to this. Absolutely fine. Now that finishes up this section. I believe, yeah, that's the last question. I was surprised that this section was so short. Now, the next two sections get absolutely gorgeous, and we start getting into more of our integration techniques with the substitution method. So please make sure you are able to do those sections. Probably section 5.7 and 5.8 are going to be our most important of the semester, because they're the substitution technique is one that you can never, ever, ever forget. So please stay tuned for those.